Okay, now the date is this. Oh, same date, but later. Just back from my parents. Okay, the normal, this vector points in the direction of green. And the meaning of that thing is basically that this times x plus that times y plus that equals 0 is the line. This, if we go in the direction of green, I want to move the line in the direction of green. That means that I add one normal vector, and which means that xy that I use here are incremented by w0 and w1 respectively. Hello, Joy. Show the bot. Say something human. Let me think. Yep. So this is the normal, and if we add normal to whatever we multiply this with, the whole thing is increased by w0 times w0 plus w1 times w1, which is the square of the length of the normal. Definitely positive. And then for that to be equal to 0 again means that we have to decrease this. In other words, a negative value corresponds with green territory here. I'm going to need yet another O-string stream, I guess. Hello, Fernando. Well, the font that I'm using is Deja Vu Sans Mono 16 point. So maybe that has everything, I don't know. For the rest, just this terminal, so it should be that font. It's supposed to be UTF-8, so yeah. Either they support it or they don't, right? So I guess they went out of their way to support it. Let me see. Just the chart const port pointer color. I don't see any blue line or what. Did something horribly go wrong? It's not complaining about it, seems. We set the line width to make it a little bit more visible. What? Yeah, there they are. I want to have them up front, maybe, so they stay visible. Or dashed up front. What am I doing here? That tool. The circle is already front. Arrow is front. Yeah, and then the other ones are also front. So I need different layers. Oi Tony, hello. No, this is not clear. I think it's not possible, I think. Something went wrong. Hey, now wait a minute. The red line is in the blue area here. What is going on? Yeah, I can't stop it. See, the red line is in the blue area and the green line is in the red area. So either I made a mistake or there's already a bug at that level. Let me just do 10 epochs and then wait. Not too much cluttering. Yeah, you see. That's an almost perfectly horizontal line anyway. Maybe I enforced that already. And the normal is, yeah, definitely. The normal is 0, 3 plus 3. So that's arrows pointing upwards. And that means that the red is green. Really, the normal should be pointing into the green area. I'm pretty sure of that. Why is this so incredibly hard to get right? I think I'm going to add something to my readme that talks about the science of things to give me a summary of insight, as it were. And maybe even not in this file. Make a new readme. Right, it belongs to the binary classification. So I'll add it somewhere here. The signs on the wall. Is that a correct word for plus or minus? Is that a sign? I think so. Need a dot. Just getting my dot here. Dot. In products between W and X, and then in the code I'm using a matrix multiplication instead of a dot product, and I use a row vector for W. I could also write W cross, so that, or T, the transposed W transpose times X. But I don't think that makes stuff very much more clear. Let's talk about in products simply here. Subscript 2. Where are you? It's already simplified. Talk about beer. No. Don't tell me I don't have a subscript tool here. Seems not. Subscript 2. something, yeah. Arch, yeah. A Fluxbox. I use Fluxbox. Is that enough? Because trying to write something. Note. Yeah. Plays the role of the bias called P above. I think Shahul Gan Cheng has a screw loose. He's asking us to enable his Wi-Fi or what? Dude, how do you manage even to get onto the internet? Oops. It's kind of non-trivial because we just have. I mean, you would, yeah. The trick with the bias makes it complicated. So we'd have to say that if you add anything to a point, then this third element must be 0. So then this is not really n, because I defined n as a two-dimensional thing here, which is probably not what we want then, or maybe, I don't know. I'm adding n all over the place to stuff. Do that like this. And prime is normal to the line. Let n is 0, so that that it can be added and subtract. From x factors. X or P. So if adding kn to a point P makes it end up on the line, then k is called the signed distance in units of n. This still holds. Okay, so Wx is what is fed into the sigmoid activation function. Maybe we should use P here. It's a bit confusing now that now here x is on the line because I defined it like that. And here's an arbitrary point. Just add it, I guess. I'm building a neural network of a single neuron. But then without looking at what everyone else did, but doing all the math myself. So I exactly understand what is going on and maybe improve upon it. Once I understand a single neuron perfectly, then we can make a step to more neurons, and then layers, and then layers with confluences, and then layers with feedbacks. But I don't want to start there, because then I won't have any idea what's going on. So P here definitely stands for an arbitrary point. Still I want to talk about X here, but okay. I'll just do it like that. In this case, X stands for the input. The output of that activation function is the density of green points, or the probability that a given point is green, by definition. Thus, the larger the value of Wx, the more we stray from the line into the green area. Yep, because the sigmoid function is a monotonic rising. If you make the input larger, then the output becomes larger as well. And larger output means into a green area. So then, well, same thing with the input. The larger, the greener. Then we say, adding n to a point, I'm going to add it to x. Adding n to a point x on the line causes w x we're changing x here, right? I mean, we're adding n to x, so then x is changed. So I can talk about wx. Because wx has become larger. So let x be a point on the line. So that wx equals 0. And then add n to it to get p. So now we talk suddenly about p. Is x plus n, and then the value of, now it is wp, equals w times p, which was x plus n, which you can write it as, how is that called? That you can do this? Alzheimer distribution or something. Wx plus Wn, and then of course that is equal to Wn because Wx was 0. And now I redefined n above here to be a three-dimensional thing. So this then equals W0, or let's start with the W0 of W. So this is the first element times the second times the first element of n, plus the second element of W times the second element of n plus the third element of w times the third element of n equals yeah, that's the length of n, sorry, but it's w0 squared plus w1 squared, and that is positive. If you don't understand that, then please leave my stream. Squares are positive. So it becomes larger, yeah? This is positive, so it is larger. Which means that we've ventured into the green area. Conclusion, and the normal n points in the direction of the green area. What other insights do we need? I do need changing W, because that's what I'm doing. Already worked it out in the code in a lot of places, what W2 actually is. I think it's a distance from the line to the origin, or the other way around. It's kind of important, I guess. It will be easy to see now. So this, if you, nah. Yeah, so we add n, the normal vector, to x, then this becomes larger. So to make that new point part of a line, we have to make that smaller. So it subtracts something from it. So if you decrease W2, then the line moves into the green area. At the moment I'm not predicting anything. I'm just trying to get an understanding or a grip on the signs of everything. Because what I'm having at the moment works except for the sign. So the plus is minus and minus is plus everywhere. But there's definitely a problem with it. I don't know where, so I just want to understand it. And then I can have a look at the code and then hopefully see, yeah, right, you know, that something is wrong there. Let's see, so decreasing the value of WT, therefore moves the line into the green area. And I want to prove it. So if we put a point P, where we add the normal, then we move into the green area. So P is now into the green area. And then I have to prove that the equation of a line going through P has a smaller W2. Wait a minute. W prime. It's a bit fake. Now I'm using the fact that this is not influenced by the value of W2. Let me just write it full out, I guess. So WP is W. Here's my equation. This prime equals 0, and these are now the P values. Yeah, plus this, right? So not working that out. I'm getting wider and wider. Guess I can do this. Right, therefore this is positive, so that must be negative. No, I'm doing something wrong now. I'm doing it wrong, damn it. Nope, no. Let's write it out. The conclusion is correct, but yeah, I want to write it out. Okay, we begin with the conclusion, and then I say let P be X, which is on the current line, on the old line, plus the normal, meaning that we go into the green area. So where X is on the old line as above, then a line through P would have the equation. A line through P would have the equation WP equals 0. Where we now use a different W2. Yeah, so then we say our P is on a line. Then what is the line equation? But we didn't change anything except the bias. So this line must have the same W0 and W1 that we had, and that is changed. And then the new P must be on that line, so it must be equal to 0. Where, well, we know then that P 0 equals x0 plus w0, because that's the x-coordinate of the normal. And this one is the y-coordinate of the normal that we add. And we want to find the change of the w2 that we have to apply. So now I can write that out. w0 times p0, where p0 is x0 plus w0. And then that one and that one equals 0. Zero equals, I wrote this, and then that, and then that. And then we can write that out as w0 times x0 plus w1 times x1 plus W2 plus W0 times W0 plus W1 times W1 plus W2. I could do it with less spaces, that would fit maybe. Yeah, well, it will have to do. Which equals, oh, I have to go to another line anyway. Okay, let's do this. Now this is 0 because that's just Wx. And these two together are the length of n. Plus that. Yeah, I don't have them ready, available-ish. Not fancy. Things years old. I have 32 gigabytes of RAM. That's what I know from my head. I think I have 16 cores. Let's repeat the conclusion. I wonder if we can also add something about the targets, because that definitely went wrong. That's more a code thing, I guess. Let's leave it like this. Well, I did a lot of effort here, so I'm gonna go with that it is correct what I did here now. So decreasing W2 means that we go into the green area. Yep. Well, with SD1 being positive, so that's pi divided by the square root of 3, totally positive. And negative SD means that we decrease the W2 component here. So the thing is into the line with a negative SD is further into the green area, and I want to draw a green line there. So if SD is negative, I draw a green line. Yep. And lo and behold, it looks like it's inside the red area. So what the fuck? If only. Copy this. What the hell? What the hell? Really? So then it must be drawing the wrong color when drawing the points. Where is it doing that? Drawing the points. I think it's just this draw. No, that's a line. This plot draws my points by target. The targets are wrong. I'm gonna go with is green is green. So if we replace is green with true, then this is just always a 1, and then everything should become green. And the rest of this function is correct. What the hell? Why would that not work? Okay, not all of them. try to work this then. Most of them. Totally green, except for 3. So that function is correct. If I fake that a lot of green is there, then it draws green. So then either is green is wrong, or I just pass targets of the wrong color. Well, I can hardly imagine that is green is wrong. Pool is green. Yeah, is green returns is green, and that's what we pass through color when constructing it. So that's like really no way. And is green means if this is true, then it is green. So yeah, green is true. So I guess that if I use green, then this was constructed with a true. And then this is true, and then that would be true, and that's just 100% correct. It cannot go wrong. No way that can go wrong. This is generating the colors, so that will be interesting to look at. Here we just passed them then, and that function we just looked at or not? No, it's another one. What target is being used for here? I'll look at that afterwards. Color. Targets is whatever is returned by generate colors. We move that as green to T. Looks all good to me. And then what is this function doing with the targets? Oh yeah, I just looked at that. Well, that's not a problem. Then the problem must be this function. Generate colors. Now, if the output of the sigmoid is the probability that something is green, that means that if it is 1, then that should always be green. And color dist is a random number between 0 and 1. So yeah, it's always less than 1. If threshold is 1, so and that is green. So I think this looks good. Which then means I'm feeding something wrong into the sigmoid. What is this minus sign doing there? It's this one minus sign, I think. Yeah, this is literally WP. So if I pass minus that to the sigmoid, then I'm not doing what I said that I would do. Even in my README. But this is the derivation. or why it should be a minus sign. So what the heck? It's kind of a do-over. Wx equals 0. Let Wx equals 0 be the line equation, where W is you know, and N is that. Same thing as is in the readme that I just wrote. Let N be that, be the normal vector with length 1 over S. Yeah, we'll even talk about the scale factor here. Sophisticated comments. Let point P is P0, P1, 1. Also 100% correct. Nothing to say about that. Let K is P plus Kn. Be on the line. Okay, so we have a random point P. We add K times the normal and then we end up on the line. That means in my book that if K is positive, then P is in the negative direction of N. So then P was red. So a red point plus a positive number of the normals, it becomes green, alright? Then we move into the green area. So let P plus Kn be on the line. EAWK equals 0. Then K is the distance from point P to the line in units of N. Well, that's totally true. The actual distance is the absolute value of Kn. For obvious reasons, that is the absolute value of the distance. Where N was a normal with length 1 over S, so that would then be equal to K divided by S. S being the result of a square root, so it's always positive. Thus, W times K, I guess, which is that, equals 0, from which follows that Wp plus K times Wn equals 0, from which follows that K equals minus Wp divided by Wn. Yep. Note that Wn is W0 squared plus W1 squared plus and so on. So that was the positive thing. The length of the normal, which is the square of the normal in this case, which is 1 over S squared. Hence the real signed distance is K over S. So the actual distance is that, but I want to keep the sign. So I'm dividing by S here. And then we end up with, this was 1 over S squared, so K is minus W dot P times S squared, and then we have to divide by S again. So we end up with a single S. You say 5, not sure what you mean. I'm not explaining anything, I'm just letting people watch what I do without having to pretend that anyone can learn from it. Anyway, the math is correct so far. Finally, we have to divide the real distance by s before passing it to the sigmoid function. I'm afraid there's just a minus sign missing in this line here. But why? The sign of k. I think the problem here is that I went from p to the line instead of the other way around. That's why I'm missing a minus sign here. I'm gonna add a minus sign and then add a comment to explain why that would be. By by s, which is trivial because you want to pass it to the sigmoid function. That's what the scale factor is about. Right, so then in the end, that's the answer. Pretty sure of it. So divide by s and cancel the sign. Now you see that the red line is in the red zone and the green line is in the green zone, and the green is on top while the normal is positive, pointing upwards into the green zone. That everything is correct in this image. And then I would say that if you do a more of an epoch than 10, then we'll see nothing happening, because now really it should be stable from the beginning, right? Yes, it's no longer changing sign. Very good. So we begin with well, these values. And that's how I generated the red and green points to begin with. So it's just the answer. And then the neuron says, well, that means that we're already there actually. more or less. Well, it changes a little bit, but not that much. Turns 0 into 100th and 0.999 into 0.98, and then we're stable. Super good. Everything finally works. What did I do? Get diff. Yeah, I set theta to 0. That's why the line is horizontal at the moment. Do I have to fix that? As a fix me. I blew it up till 6 times the standard deviation. I think 6 is just a ridiculous amount, but well. And then we have better colors. And the bug fix. The bug fix that this stream was about and that we ran into yesterday. More better colors. Yeah, and this is just a backpropagation implementation now. Apparently I never even push that yet. I'm not too happy with this though, but okay, this is the next step. The idea is, of course, that the gradient that you calculate really points into the steepest direction, and then if I change one of them by a factor of yeah, I don't know. I should remove that. Did make it more stable though with a large learning rate, but let's remove it. And I'll make this smaller learning rate. Right, now it looks good to me. Stable like hell. Not just stable, but also near the perfect solution. It's a little bit rotated, but yeah, why not? I mean, these points are randomly distributed. Oh, this one is moving. Slowly. But I guess in the end it's stabilizing as well. Can you zoom in? Would be kind of nice if you could zoom in. I don't think you can. Yeah. Holy god, oh well, no, okay. I thought it was exactly the same, but changed a little bit. Right, well, I guess the next step is making beginning with a random weight matrix, and then see if it also stabilizes and how fast. So at the moment I start with a copy of the line itself, which is ridiculous. Can just construct a new one, passing a random generator. Get an arbitrary other line. Should do it. Yeah. Do we have a random generator here? Yeah, even that. So instead of starting with the answer, we just generate a new one. So the blue line here is the line that we use to generate the distribution of red-green, and the red line here is the distance of 1 times the standard deviation that I used. And it's not getting there, right? It's close enough, but I wonder why we don't see a diagonal line, at least one. I think I'm only printing it, showing it after 100 epochs, and it seems that the slope, say the direction which the line runs, has already been predicted like perfectly, long before the offset has been found. Strange, but so yeah, it's all parallel lines because of that. What I can do, of course, is draw that very first one as well. The reason is not printing it. Let's see, this is even after the weights were already adjusted here. Yeah, I just have to draw it before I do that. I think that should work. And then as epoch we use also 1. Who cares? Yeah. Yep. So now you see the initial values, yeah? And these are 1,000 times later. So it's probably more interesting to see the rotation as well. Let's do a drawing. Oh, but 10 even. Wow, that's going fast. So like this we are going to see all of them, every epoch. Now you see the rotation. And then moving. The moving is whoa slow compared to the rotation. Super slow. If it even gets there. It's not even close to the green line here. It's much narrower. Strange. Nah. We have another bug then. It's creeping closer to the red line though. That is definitely the case. It likes a red line, it seems, but the blue line is here. And the green line is here. There's a huge distance. That should not occur. I think we still have a bug. This is not correct. Or at least very, very strange. Ooh, what's happening? What is happening? No, in unstable shit. Wow. What? It's bouncing between two different angles. Not much to see anymore. You can still look at the green one though. The green line is here. I don't know if you can see it. And this forefront here is what should move to the green line. So it seems to be rotating back now. Let's stop it. I want to see the seed of this. You can still see it. Seed 9,370. Let's try every 100. Let's see how we get closer in the end. It's still working. Do we have another zombie or what? There's another one still running. What the hell? Oh, that was that one. What's that one thing that I started yesterday? And oh, we waited for it. It's still running. It's never finished. Oh my god, unbelievable. Oh, I just kill all GNU plot. Actually, it did print something, and yes, it inverted the signs. So not that bad, actually. Okay, now we're here. So, not sure where the red line is. It seems to have found the green line pretty well. And the blue line as well. So then I guess the red line was here. No, it's stable. So this is the real line. And in the end, we did that. Found this. Wow, it's pretty good. It's pretty good. Can't complain. Santosh, yeah, I see you. Not sure what you want to be taught though. You can read my my files. Let me commit what I have at the moment. Git commit git status here. Git commit everything. So that ended up here. Backpropagation is being shown here. So the two readmes that I wrote, which kind of summarize. It's just pretty. It's like a book form of everything I learned in the last month. So if you read those two and you understand them, then you know as much as I do, I think. Certainly, if you also look at the code and then understand that as well, it's going to be a lot of study, you know. You can't expect this. You can't expect it to understand it in an hour. or in a day. It took me a month, so yeah, study. I'll give you the link here. Well, if you really want to dive into it the way I did, then I guess it's a good idea to try to compile it and run it and get that to work. For a start. You probably have to be on Linux. You're going to need to understand linear algebra to be able to read the readmes. Let me see if you don't know that, then let me see if I can find something that will teach you. Wikipedia. It's called distributivity. I think I call the distributions are not far off. I don't find it super to the point or clear, for that matter. It's more than you need. Just look at the dot product or something. Just, yeah, the only, I don't know, that's the most important thing that I use. Dot product. That's also vague. I wouldn't really want to talk about. I mean, it's true. You can see. I mean, if you want to say the dot product means, I mean, you have two vectors, then the dot product is the projection of one on the other, and then the length thereof. But then I think you have to project onto a unit vector, so the length of b must be 1. Or you have to still divide by that. It's a bit vague. Or you could say it's, but that's the same thing as that projection idea. It's the length of one vector times the length of the other vector times the cosine of the angle between them. But that's just one way to look at the dot product. And I'm not using the fact that it has a lot to do with the projection at all, really. Well, not really, no. This is the most important thing that I'm just using a lot. If you have two vectors and you take the dot product between them, then you just have to multiply element-wise the two and add that. So the first element of both multiplied plus the second element of both multiplied plus the third element of both multiplied, etc. And that then happens to be the length of A times the length of B times cosine of the angle between them. So the most important thing get away from dot products is that if the angle is 90 degrees, then the cosine is 0. Then of course the result is 0. So if two vectors make an angle of 90 degrees, then their dot product is 0. And that of course you would also understand if you talk about projection. If you project one vector onto another vector and they make an angle of 90 degrees, and you get nothing. So length of nothing is 0. So yeah, you get 0. And if they are, if they're parallel, they have the same direction, and the cosine is 1. So then the dot product is just the same as the multiplication of the two lengths. Oh. Let me read. You want to learn something like time series regression. I don't even know what it is. Kalman filter. Never looked at it. No, I'm just figuring out stuff myself. And I think that you're ahead of me in terms of difficult subjects. Could look it up, but until I need it myself, I'm not really motivated to dive into something. Right now, my concern is with this single neuron still, because it's rotating fast and then it's going so slow. Why? How does that make sense? I would like to see a 3D graph where you literally see a descent. I can still do that now because I have only one neuron. How many dimensions is my graph of my whatever space? I think 4 dimensionals already. I have 2 weights and 1 bias. So yeah, it's ridiculous, but you need a lobotomized neuron in order to make an actual graph of it, where you can see the gradient, the descent. Which is unfortunate, because if I want to see why the rotation is so fast and then the bias is so slow, I need all of them. So I would really need to draw something 4-dimensional. Which is not possible, so yeah, the only other way is then to try to understand it using mathematics. I really want to, just really, I mean, this is very unsatisfying. The way, why is it so slow? You know, what's going on? Is my gradient the actual gradient? I don't even have a loss function. I skipped that. It's annoying in itself. So maybe I should define some loss function, and then we can actually look. I can just vary the weights a little bit and then see the change in that loss function. And then we just numerically determine the actual gradient, and then can compare it with the gradient that I'm calculating. So this here, the G. And then see if it is off or not, or that it is correct. If you look at this code, which is super simple, and there is no way you can understand what's going on. No way. At least I don't. I understand this part and this one as well, actually. This is just multiplying the weights with the inputs and adding the bias, and we put that into the activation function. And then I'm doing something ridiculous where nobody knows what that is, and this I just got from pages and pages of mathematics, and it turns out to be the simplest thing on earth. But yeah, absolutely no, I don't find it intuitive, let's put it that way. And then what the hell, we multiply that with x to get g. No. Yep, you lost me here. And the reason that I'm losing myself even is that the actual mathematics behind it is difficult. This is the delta here. So the delta ends up to be z minus t. But why? Well, the reason is that the reason is super complicated. Super complicated. The reason is that it actually comes from this. Where this is the derivative of the sigmoid with an output of z. Happens to be z times 1 minus z. So the output of the sigmoid is z. Then the derivative of the sigmoid at that point is that same output times 1 minus. You can show that with the whole exponential equation that is the case. So this is the derivative of the sigmoid, the activation function with respect to z, the output itself. What? That doesn't make any sense. Actually it is, yeah. Sigmoid is this step function thing, smooth. Then the derivative relative to its own output. We have to multiply that with the xi, and I also don't know what xi is, or actually I do. And the xi is the change in the loss function as a result of a change in, again, the activation function output. And I derived that it is a good idea to use -1 over z minus 1 if the target is red, and -1 over just z if the target is green. And since t is only 0 or 1 and never something in between, you can short circuit that. But we don't need that, because this means that if you multiply the xi with the derivative of the sigmoid function, which is this, then one of these terms drops out. So depending on the target, then either this divides that away or this divides that away, and you just keep the other one. And that depends on t. So if t equals 0, the delta is z if t equals 0. Why? Because then if t equals 0, you divide by 1 over 1 minus z, so this drops out and you just leave the z. And if the t is 1, then the xi is this, so you remove that one factor, and the -1 turns this around, so you get z minus 1. And then you can combine those two, because yeah, well, I mean, if that's the case, I might as well write it like that. So if t now equals 0, we have just z, and if t equals 1, then we have z minus 1. But to understand that, you have to understand what delta and xi are. Well, xi was dl dz, and delta is xi times that, so that is dl dz times d sigma dz. Doesn't make any sense. That's why I call it magic, I guess. I believe the loss function gets z as the input, right? Yeah. So we can integrate this, and then we have the loss function. Then I would have I could integrate this function. That should work. As a loss function, I guess. See, I used the fact that t can only be 0 or 1 several times to just rewrite the formulas, as it were. It makes it really strange. Well, this is just a trick to say if t equals 1, then this is 0, so we can ignore that term. And this is 1, so if t equals 1, that is what we should use. And if t equals 0, then, well, this drops out. And this is just 1, so that is that. So it's really a switch. If the target is red, you want to use this, and if the target is green, you want to use that. And then you just combine it like that and magic. Yep. However, I believe that it's all there. So it is theoretically possible to understand this file. If you start at the top and then not be satisfied with not understanding something, which is every line you must understand where it came from. That should be possible. It starts all the way up here. And yeah, well, you will understand that I did a month, well, a few weeks about this file, this README. Several hours a day. There's no way I can explain that again. I even started to forget it already. What is this all about? Maybe you can skip this part. It's a lot of math, and the only thing in the end that I did with it is write this line. This proves that minus the log of the likeliness is a suitable and stable loss function. It definitely would help, I think, if I have a loss function. And that way you can really determine what the gradient is. And the magic with the C and the delta is really to short circuit empty tensors. You know, the real story is evolving three-dimensional tensors. Even with a single neuron, and it seems like a kind of a waste because most of those tensors are then 0. So I reduced the dimensions of stuff and then ended up with the Xi and the delta trick, and that's described in the README backpropagation. This starts with well, the real thing, so then you have three-dimensional stuff. This is definitely the file that you should start with. See if I can find a three-dimensional one. Yeah, here. The gradient of f with respect to q is a three-dimensional tensor. So this looks like a matrix, but each element is again a vector perpendicular to the other two rings. As you can see, a lot of zeros, and this is exactly the same thing as that. So it's just ridiculous to really work with that. But I worked it out anyway, you know, and it's a lot more logical, I guess. If you work with this, you know, there's just a chain rule. Gradient of gradient of L with respect to Q is just with respect to L. If you reverse the order, then you see that everything drops out. So the O drops. Oops. Gradient of O. It's more like L O. O drops out F. F drops out Q, and then you end up with with delta QL. You have to be careful to not reorder matrices. So, and while these things are kind of matrices, I have them in this order. But like I said, if you just do it reverse order, then it becomes much clearer that you can apply the chain rule. So in the simple, if you replace a gradient with partial derivatives, then this would become df slash dq, and here we would have do, I think. No, it must be the other way around. Sorry. This was dq, df. This is then df, dq. Wow. do. And this is do, dl. And then if you just literally see these things as tiny changes, then you divide by tiny change and then you multiply again with it. So these two drop out and these two drop out, so what you end up with is that divided by that chain rule. And then you can convert it back to the gradient, and you have that thing. There is logic behind it, believe it or not. I'm looking, I think this is then the first time I use delta. Yeah. So instead of doing 3 tensor multiplications, we can note that effectively that, and now we have no gradients anymore, but matrices with just I and j, so 2-dimensional matrix at most. And this is then per element. So this is a matrix with I running over the rows and j running over the columns. And then per element you can just write that. And if you understand what is here, then you understand this part as well. Oops. And once you understand that, then you also understand what delta is, because now we just short circuit that. This is kind of the definition of the delta. Repeat it here. So delta is that. Yeah, here we have the x. So the delta times x, where x is the input of the neuron, is the derivative of the loss function with respect to the weights and bias. So this is what I'm doing in that last line here. So g is this, and here you delta times x, so delta times x. Well, this is without samples. So the contractor is over the samples. So it's really, I think this for each sample and then summed over all samples, and then in the end you really should divide again by the sample size, but I'm only doing that here now, so it's not really the correct G. Maybe I should change that, although I don't think I can divide by a tensor. I cannot divide a tensor at the moment by a scalar. I can only multiply it. So I thought, why not, you know, I have to multiply it with learning rate anyway. So let's do floating point divided by a floating point, and only then multiply it with every element of this matrix. Otherwise, I would have to divide every element here by this, and then multiply it again with 0.1. So that seems a bit. No. That's like some overall samples divided by the number of samples, but we do that in the next line. I have to look at the what? It opens in a different monitor. Union the best option here. 12 hours ago. Why do I get a notification 12 hours after being posted? Try to create a generic dynamic array. Oh, it is C. Gotta wonder why people want to program in C when you can also do it in C++. It supports that kind of stuff. slightly weird though. I'm pretty sure that Z is the... I use Z as the output of the activation function all the time. And this is definitely not that. It's not X, let's put it that way. This is the output of the sigma function. The ZDW is, yeah. Derivative of the activation function times X. That seems correct. I guess I combined it. So this is the derivative of the activation function times X. And I would write it as delta X because then the derivative of the activation function is taken together with that one. There. So that would be then that delta is this times, yeah, delta not defined earlier. So kind of what it says here. Could have written it a little bit more clear, I think. What the hell are you using delta for the first time? Yeah, that is unclear. This is where delta is used for the first time? You could be kidding me. Where it comes from this, that's where the delta comes from, so I should be reading that. Bleep, bleep, plop, plop. Yeah, this is better. So this is the delta and that is the z here. But here I'm using O and F and Q. So not the same characters that I use in the other one. Let's try to find the LDW with this one. Comes from there. It's just the same thing. Yep, I think I should integrate this with respect to Z0S, and then I get my loss function. Looks like that is the logarithm of for this. Minus the logarithm of that even. Not quite. Loss function should combine all samples. So we have to do something with the S then. I guess it's just going to be, we're talking about minus a logarithm. That should be that's the loss function. It's like literally minus the log of something, writable as the minus the sum over all samples of the log of something. So this is where we came from, but in the end you might as well use something else because the derivative is the same. Did I say that correctly? Yep. If t is 1, then this drops out and we get minus 1 over z. T is 0, then it is minus 1 divided by z minus 1. Or 1 divided by 1 minus z, which is this one. So that's equivalent. And well, L and loss are the same thing. I don't know why I'm using a. Well, I'm using L because I don't want to write loss here. And here I write loss. Maybe I should write L here. Everyone understands what that is. Loss function. This becomes L again. Again loss function. Now I have two. The loss function. Oh. Well, this is a loss function. Okay. Yeah. Anyway. So now I can replace that with that as if. And then just remove this and put in that. Because why not? Yep. Well, that then is interesting because then we can actually calculate loss function value and therefore also the gradient by simply trying what happens. I wanted to click on that one actually. It's exactly the same as what I have. So it does exist. Yeah, cool. So if the target is 0, then this drops out, and this is 1 times that. So it's a log of 1 minus z. The log of... Oh, wait a minute. It's inverse. I have z minus 1. What did I say? If t is 0, yeah. If t is 0, I have z minus 1 instead of 1 minus z. And if t is 1, then we just have the log of z. So I just inverse this. Yeah, it is, my formula is bullshit. It has to be this one. You can't take the logarithm of a negative number. So if t is equals 0, then this is always negative. It's just nonsense. I must have made a mistake somewhere. Assuming I made a mistake, and what I actually have is well, then this, right? Then it already existed, which I actually feel as an encouragement. It means that I really reinvented the status quo of what is being used. Well, it means I'm capable of continuing doing that, right? Finding the right solutions. But I'm not happy with that. This is just negative. Why? Bloody thing changes sign depending on t. Well, this is positive. As the output of sigmoid, so that is between 0 and 1. And then subtracting that from 1 is positive, so the whole thing is positive. But this is negative. I think I'm doing my integration wrong. Let's do it indeed the same way as they did. This is kind of, yeah, apparently not working. Let's put it that way. So instead we're going to integrate it in parts. So I can do steel. So I start with ts times log. So this works, this should be the integral of the case t equals 1, which is this one. So I need the integral of that, which is the log with a minus sign in front of it. Isn't it? Yeah. So the minus sign stays then here, and this becomes the log. So this is correct for t equals 1. Because that's this case, and if you take the derivative of this, is 1 over z, and the minus just stays, so you get that. Let's remove that. And then plus, I don't know, 1 minus t. So this is 1 when t equals 0, and 0 when t equals 1, so that's good. And then we get the other case where t equals 0, so I must integrate this, and that is just the integral of, yeah, I got my minus signs mixed up again. Of course, it's just the log of that. But then with the minus sign in front of it, because we have a minus sign here, and I really want to end up with that. Now let's compare it with what they had. Plus 1 minus t. Nah. Still a difference there. So, bullshit remark here. Makes no sense whatsoever. I would say the opposite. If there's close to t, so t here is 0, z is 0, then you take the log of 1, which is 0. 0 minus 0 is 0, and 0 plus 0 is also 0, so no. I think I should stop and go eat. Yeah. Let's do that. I'm just scared I made a mistake and that it's not correct. Life is so much easier when everything is correct. Because, I mean, if this is my loss function, then we can continue. But if it isn't, then I'm wasting time. So is this an error? Or is this indeed a different loss function? Let's calculate it. I guess if this is my loss function, then it should go down all the time. Then I probably did not make a mistake. So in the middle of my epoch, I can just calculate it here. We want to calculate that, which means I want to run over all axes. It's the same as I did here. So just run over all the points. Keeping track over J, I think. Do the same thing. I need access to both the vector, the points, and the target. So let's just run over j. I don't know why I use j now, but and that was because I is already used probably. I don't know. J. So obviously the number of points, right? Yep. Point size. And then casting it to an int because C++ is flawed. And then if the target equals 0, else because that's my t. And then x 0 and 1 comma j are my points apparently. Let's define there. You'll have to calculate rather have to calculate z. I think I already have all my z values here, but j is a sample size. Okay. So I didn't want to use s here. That's why I was using j. So really we're running over the sum here. I want to create a sum. Let's make a loss function loss. That's totally wrong, but hey, it's a beginning. So if t equals 0, then we have this one, and that minus and minus drops away, so we want to add the logarithm of 1 minus z if t equals 0. So it's the other way around. And then if t equals not 0, aka 1, then this drops out and we want to subtract the logarithm of z. Furthermore, is it Z0J or what is it? I have a Z here, but it's activation of V, and V is this, which is W times X, which is, I guess, a row vector of samples, so that's 0, j. Yep, okay, now. And then we can print it. Loss is loss. It's quite dubious here. That doesn't go down. The absolute value goes down. Why is it negative? Yeah, it definitely is looking for the maximum value here. But no. Let's try another one. Oh, that doesn't work. It's the same one. To change the seats. Quite happy with it, I have to say, except that that's negative. What did I expect? The output of the logarithm is... Gee, no idea, man. What should we expect here? Can go either way, huh? Can't it? I mean, there's a plus and a minus, which is the whole point, the whole confusion. Maybe this should also be a plus. I don't know. All these terms are less than 1, so the logarithm is going to return a negative value. All the logarithms are negative. Apparently this one is more negative than the other one, or we have more t is zeros, which is logical when you have a so the line is shifted outside of view, so we just have a lot, well, not outside of view, but somewhere up here. So we have a lot of red points here. Then we have more red points than green points, because it's simply, well, there's more red points than green points. The line was shifted a bit. More red means t is more often 0, which means it's a negative value. So we definitely should see a positive value as well. If we have more green, it says positive, totally positive. Okay, I'm happy. Now it goes down. So my loss is a bit weird. It's not always going down. Just the absolute value is going down. What? I think I'm definitely doing something new here. It's not a gradient descent anymore. It's a gradient towards the correct solution. And not a descent. This one starts negative again. It's a gradient towards absolute value of the loss becoming less and less. Ooh, this one goes past 0, so take that back. What's happening? What the? Well, in the sense that it searches for a minimum, but doesn't have to be 0 at all here. And that it is negative, I would say, is because we have more red than green, but we don't. That is certainly weird. On the other hand, you know, should this block do anything at all? All those green points here. The target T is 1. Yep. And the Z is also 1. So what is the result for my loss then? For all those points. Target T is 1 and the Z is 1. Yeah, that's a log of 1. So that's just subtracting a lot of zeros. Doesn't really do much then. Points outside of the 3 times, 4 times the standard deviation don't add anything or subtract anything for that matter. It's more, I think the question is how many points do we have, red or green points do we have at the end here where we cut it off. There's a diagonal cut off here. This is a bad example. An even worse example. Keep having bad examples. This is a better example, I guess. No. Also not. Why is that 45 degrees all the time? Yeah, this is better. So here we have, if this is the line, the correct line, then we cut off all these red points here. And we add just a few green ones. And here, wait a minute, that's not correct, of course. We add a few green here and we cut a few red off. But that should balance. And here's the same thing. Green, well, not the same thing, the opposite thing. So yeah, you can just move this triangle to there, and move this triangle to there, and then it's looking like that, totally perpendicular to the line. So no. What is my loss then? 9.6. So looking for a maximum here. Does that have to do with the sign of one of these things here? So we're going up in the case mine is positive. This one is also minus positive, and we're also going up. And this one is going down. It is minus minus. So it could be the sign of the thing in the middle here that determines which direction we're going. Could be. Let's see. So this one went down and it was a negative, and this one goes up and it is positive. Yeah, so the sign of the first one doesn't matter, apparently. Well, I guess the reason is that it's still working. No. Everything is positive and it's going up. What the hell? I'm going to cook dinner. Thank you for keeping me company, peoples.